This is the program to find the roots of a quadratic equation. To write the program, we have to follow 3 steps. First step is we have to understand what is the mathematical background behind this quadratic equation. Second step is we have to understand flowchart. Third and final step is we have to write down the program. Step number 1, let us understand what is the mathematical background behind this quadratic equation. What is the general form of a quadratic equation? General form of a quadratic equation is like this: ax square plus bx plus c is equal to 0. Let us call it as equation number 1. Then what is the general solution of a quadratic equation? General solution of a quadratic equation is like this: x is equal to minus b plus or minus within the square root b square minus 4ac by 2a. Let us call it as expression number 2. To find the value of x, we require the values of a, b and c. Values of a, b and c are called as coefficients of a quadratic equation. User can possible to enter any values for a, b and c. In this is the case, if user going to be enter the value of a is equal to 0, then this term is going to become 0. If entered value of a is equal to 0, this term is going to become 0. Remaining thing is bx plus is equal to 0. This is nothing but a linear equation. That is, if entered value of a is equal to 0, then equation number 1 is going to become bx plus c is equal to 0. Why? Because this term is going to become 0. Remaining thing is bx plus c is equal to 0. This is nothing but a linear equation. So that bx plus c is equal to 0. This is expression is not a quadratic equation. So that we could not be able to find the value of x using this expression. Directly let us find the what is the value of x. X is equal to minus c by b. We got only one solution. Why? Because whenever a is equal to 0, this expression is going to become linear equation. So that we got only one solution, that is x is equal to minus c by b. Let us call this solution is 1. We got only one solution. Why? Because this is a linear equation. Next, let us move on to if a is not equivalent to 0. Second main case, if value of a is not equivalent to 0, then we could be able to go for this expression b square minus 4ac is called as a discriminant. So that let capital D is equal to b square minus 4ac. Let us substitute this value in the equation number 2. Then equation number 2 is going to become like this: x is equal to minus b plus or minus square root of capital D by 2a. Let us call this expression as 3. Then within the second main first case, if that value of d is greater than 0, that is positive, then x is equal to minus b plus or minus root of d by 2a itself. Then x1 is equal to minus b plus square root of d by 2a. Second root is x2 is equal to minus b minus square root of d by 2a. We got two roots. Why? Because it is a quadratic equation. Let us call it as solution number 2. These roots are called as real and distinct. Next, let us move on to value of d is less than 0, that is negative. Second main, second case, if capital D value is less than 0, that is negative. So that x is equal to minus b plus or minus square root of d by 2a. Here it is value of d itself is negative, so that we could not be able to find the square root of it. You can see here x is equal to minus b plus or minus square root of d. Let us multiply the value of d by minus 1. To compensate, we have to go for once again minus 1 divided by 2a. Then x is equal to minus b plus or minus within the square root minus d star minus 1, right? Then divided by 2a. It is equivalent to x is equal to minus b plus or minus, let us split this part, square root of minus d into square root of minus 1 by 2a. Then x is equal to minus b plus or minus square root of minus d into square root of minus 1 is nothing but a I, where I is equal to what? Square root of minus 1 divided by 2a. Then x is equal to minus b plus or minus I square root of minus d by 2a. Then x is equal to, right now let us split the denominator, minus b by 2a plus or minus I square root of minus d by 2a. Then x is equal to, this is nothing but a real part of a complex number, this is imaginary part of a complex number. So that let us write down like this, rp means that real part, plus or minus ip means that imaginary part, where rp is equal to minus b by 2a, ip is equal to square root of minus d by 2a. Finally, let us go for solution. x1 is equal to rp plus ip. x1 is equal to rp plus ip. This is first solution. Second solution is x2 equals rp minus ip. This is nothing but a solution number 3, where x1 and x2 are complex and distinct. Next thing is we have to move on to equivalent to 0. In second main, third case, if that value of d is equivalent to 0, that is 0 itself. Let us write down the equation number 3 as it is. X is equal to minus b plus or minus square root of d by 2a. Whenever d is equal to 0, this term is going to become 0. Remaining thing is x is equal to minus b by 2a only. Right now we got only one solution. This is a quadratic equation, so that we have to write down as it is 2 times. x1 is equal to minus b by 2a, x2 is equal to minus b by 2a. These are solution number 4. These roots are called as what? Roots are real and same. Same means to say that both are equal. It finishes off mathematical background behind this quadratic equation. Next, let us move on to flowchart. Now let us start this flowchart using oval shape. Within this, start. In quadratic equation, we are planning to find the value of x. To find the value of x, we require the values of a, b and c. So that we have to read the values of a, b and c. To read the values of a, b and c, we have to go for parallelogram. Within that, instruction is like this: read a, b, c. After getting the values of a, b and c, first thing is we have to check it out whether that value of a is equivalent to 0 or not. That is the first main. Within this rhombus, if a is equivalent to 0, question mark, this condition may be true, it may be false. If a is equal to 0, if it is true, then we have to find the value of x using this expression. To find the value of x, it is nothing but a calculation, so that we have to go for rectangle. Within that rectangle, let us find the value of x is equal to minus c by b. After finding the value of x, before going to display that value, let us display characteristics of quadratic equation. Characteristic is like this: only one solution. Using print within the double quotation, only one solution. There onwards, let us display the value of x. This is output, so that we have placed within parallelogram, then stops. Next thing is, if a is equivalent to 0, when it is false, means that second main, that is, if a is not equivalent to 0, this is the case. First thing is we have to find the value of d using this formula. That's what we are going to be shown in the flowchart. D is equal to b square minus 4ac. After finding the value of d, what is the next step? We have to check it out whether that value of d is positive or not. This is the second main, first case. To check that value, once again we have to go for rhombus. If value of d is greater than 0, question mark. This condition may be true, this condition may be false. If it is true, then we have to find the values of x1 and x2 using this formula. x1 is equal to minus b plus root of d by 2a. This is first root. Second root is x2 is equal to minus b minus root of d by 2a. After finding the values of x1 and x2, first thing is let us display characteristics of roots. Roots are real and distinct. Print roots are real and distinct. Then print x1 comma x2 within parallelogram and stop. If d value is greater than 0 is false, then what is the next step? Next step is like this. Within the second case, if d value less than 0, that is negative. Once again we have to go for rhombus to check this condition. If capital D value less than 0 question mark, if this condition is true, then find the value of Rp and Ip. Rp is equal to what? Rp equals minus b by 2a. Ip is equal to square root of minus d by 2a. Then what are the characteristics of roots? Roots are complex and distinct. Then let us display x1 and x2 value. Print, this is first root is Rp within the double quotation plus I comma Ip. Then second root is Rp minus Ip. Print Rp comma within the double quotation minus I, then Ip. It finishes. Then we have to stop. If that value of d is less than 0, if it is false, then automatically d value should be 0. Then let us find the value of x1 and x2. x1 equals minus b by 2a, x2 also minus b by 2a itself. Before going to display these two values, what are the characteristics of roots? Roots are real and same. Print within the double quotation, roots are real and same. Then print x1 comma x2. Stop. Last step is stop. It finishes. Now third and final step is writing the program. Let us write this program using Python. This is Python. Let us follow the flowchart. Flowchart is like this. First thing is, in this example we have to find the square root of a number, so that let us import a package math. Next thing is, let us start from the beginning of flowchart. First step is read the values of a, b and c, so that through the print statement let us request to the user to enter coefficients of a quadratic equation. What is the next step? We have to read the values of a, b and c through the input function. Python read the data from the user in string format. That's what we have to split using split function. Then converts into float using typecast method. After that one, next step is we have to check it out whether that value of a is equivalent to 0 or not. So that if a is equivalent to 0, you can see here in flowchart a is equivalent to 0. If it is true, then we have to find the value of x using this expression, so that x is equal to minus c by b. There onwards, before going to display the value of x, characteristics of roots. Characteristics of roots are like this. Given coefficient forms a linear equation, so that only one solution. What is that solution? That solution is x value, that is root is equal to x. Here only let us execute this program. You can see here prompt is like this: enter coefficients of a quadratic equation. To execute this part, a value should be 0, so that let us enter 0. Simple values are 2 and 10. What is our expected result? Minus c by b means to say that minus 10 by 2, minus 10 by 2 means to say that minus 5. You can see here root is equal to minus 5. We got the correct result. Next let us move on to next part. If a is equal to 0, when it is false, then what? Then we have to find the value of d using this expression. In program else, we have to find the value of d using this expression. After finding the value of d, we have to check it out that value of d is greater than 0 or not. For that purpose, let us go for if statement. If d value is greater than 0, if it is true, then x1 is equal to like this, x2 is equal to this one. then x1 is equal to this one, and then x2 is equal to this one. Before going to display the values of x1 and x2, first thing is let us display characteristics of roots. Characteristics of roots are like this: roots are real and different. Then root 1 is equal to x1, root 2 is equal to x2. Here only let us execute once again. A value should not be 0, so that let us enter 1. D value should be positive, so that 4 and 1, and press enter key. You can see here roots are real and different. Roots are real and different. We got R1 and R2 values are like this. Then if D greater than 0 is false, then what? Once again we have to check the another condition using elif statement. D less than 0, when this condition is true, if D value less than 0, then we have to calculate RP and IP values. RP is equal to this one, IP is equal to this one. There onwards, R1 equals complex of RP comma IP, R2 equals complex of RP comma minus IP. Before going to display these two values, first thing is let us display using print statement characteristics of roots. Characteristics of roots are like this: roots are complex and different, and root 1 is equal to R1, root 2 is equal to R2. Here only let us execute this program. Once again a value should not be 0, so that let us go for simple values 1 1 1. Right now we are expecting complex number. You can see here we got roots are complex and different. Then let us move furthermore. If D value less than 0 is false, then we have to find x1 and x2 values using these two expressions. R1 equals R2 equals minus C by 2A. R1 is equivalent to R2, both are same, so that R1 equals R2 is equal to minus C by 2A. Before going to display the values of R1 and R2, let us display characteristics of roots. Characteristics of roots are like this: roots are real and equal. Root 1 is equal to R1, root 2 is equal to R2. Let us execute once again. Once again A value should not be equivalent to 0, 1 2 1. What is our expected result? Roots are real and equal. You can see here roots are real and equal. R1 is equal to minus 0.5, R2 is equal to minus 0.5. Both are equal and real. Final program is like this. Please make a note of this program and execute yourself. Thanks for being with us. Thank you one and all.